sunlight or solar power is one of the cleanest sources of energy that does not pollute the environment. As there are no pollution emissions, solar power energy has gained much attention as sustainable renewable energy technology. But what happens if the solar panels used in these photovoltaic power generation are damaged or reach the end of their useful lifespan? According to the International Energy Agency, it is expected that the volume of waste solar panels will increase exponentially throughout the world. Fortunately, we know that more than 80% of the main materials of these solar panels can be recycled when they are properly recovered. Therefore, waste solar panel recycling technology is essential to ensure the sustainability of solar power generation by maximizing resource cycle efficiency. Here, we would like to announce that Korea Institute of Energy Research has developed its own solar waste panel recycling technology. What's more, KIER was also successful in developing the technology to produce high-efficiency solar cells from the recovered materials. Let us now take a closer look. There are three primary types of technologies for recycling solar panels. First is thermal treatment technology. The second type is the chemical treatment technology. The last of the three types, the physical treatment approach, is a technology used by most nations around the world. Despite adopting the physical treatment approach, which has the lowest recycling costs, Korea Institute of Energy Research drastically improved the purity of the recovered materials. This technology has made it possible to collect more diverse materials as well. While previous methods only allowed for the separation and recovery of glass, we can now recover various high added value materials, including aluminum, silicon, and copper.
As mentioned earlier, Korea Institute of Energy Research has developed a differentiated, low-cost recycling technology for solar waste panels. Through this technology, we can protect our environment by recycling solar panel waste instead of creating landfills or incinerating such waste, and at the same time, obtain economic benefits by turning the collected materials into resources. I believe we can state that KIER has developed a technology that has both high environmental and economic value. It is a low-cost approach based on the physical approach, yet a low-energy technology that has reduced the energy consumption required in the recycling process. Mixing between the module parts and materials is minimized during the separation and recovery process to achieve a drastically higher purity of the collected materials, as well as more diversity in the materials recovered. The low-cost solar waste panel recycling technology separates and recovers components from the crystalline silicon solar panel. The recycling process goes through the stages of automated dismantling of the frame junction box, separation of glass, and collection of viable metals. However, the process is not yet finished. Once removed, additional physical and chemical treatments are applied to individually recover useful materials, such as silicon, silver, and copper, and turn them into reusable resources. The core of the process is the glass separation technology, which boasts a glass recovery rate of nearly 100%. This technology involves the use of a self-developed device to separate the interface of glass and the encapsulant of the solar panel, whose role is to protect the glass and the solar power modules from external exposure. Here at the recycling center, solar waste panels are processed to recover valuable materials, for which we can obtain silver, silicon, and copper. As mixing of the recovered parts and materials is blocked at the source, their resale allows for impressive profitability. Now, let's go in and take a look.
이 장비가 패널을 해체하는 역할을 수행하는 것이죠. 로더에 패널이 안착이 되면 위에 비전 카메라가 패널의 정보를 스캔합니다. 이런 모듈의 사이즈, 정션 박스 위치 등을 센싱해서 그에 맞는 적절한 해체 동작을 수행하는 것이죠. 여기가 모듈로부터 정션 박스가 탈착이 되는 곳입니다. 그 이후에 모듈이 이동을 해서 이쪽 파트에서는 프레임이 모듈로부터 탈착이 돼서 회수가 되는 곳입니다.
Amazing. This device performs the separation of glass from the module. Now, let us talk to the expert who's engaged in the development of solar recycling technology and learn about how the technology works.
태양광 패널은 유리, 봉지재, 태양전지, 백시트 등이 적층되어서 만들어집니다. 본 장비는 유리와 봉지재 계면을 물리적으로 분리하는 장비입니다. 즉, 패널을 구성하고 있는 유리와 금속을 분리시켜주는 장비가 되는 것이죠. 가장 큰 장점으로는 모듈의 전체 파쇄 없이 소재를 회수할 수 있다는 것입니다.
According to our expert, glass makes up more than 65% of the solar panel module. This glass is a high-grade glass with less than 200 parts per million iron content, which is naturally much more expensive than ordinary glass. Since it is an expensive material, it is important to recover the glass in its highest purity possible, right? In the past, silicon metal was likely to be mixed during the crushing process, which was a problem as the resale price of the collected glass fell below 30%. Therefore, the research team here worked to identify a method to fundamentally block the metals from mixing. As a result, the team has developed a technology to separate glass without breaking the solar module. It also has the additional benefit that this device can process all waste panel modules regardless of their state, whether broken or in normal condition. Now we call this an ingot. It is a 6-inch single crystal ingot manufactured by using the silicon recovered from the waste panel. Where do you think this will be used and how?
모래로부터 태양광용 폴리실리콘 원료를 만드는 단계는 태양광 패널 전체 제조 공정에서 가장 많은 에너지가 소모되는 단계입니다. 재활용 실리콘을 사용하게 되면 공정 단계도 줄일 수 있고 에너지 소모도 줄일 수 있기 때문에 탄소 배출도 크게 줄일 수가 있습니다.
At KIER Institute of Energy Research, we do not implement processes specialized in the use of recycled materials. By leveraging on ordinary solar cell production processes, KIER manufactures high-efficiency, low-carbon solar cells. In order to ensure a complete economic cycle, we use the recycled silicon for the production of solar cells. The recycling rate of silicon, which was particularly hard to recycle, has been improved drastically. Taking on the recent role as the anode materials for lithium secondary batteries, the value of silicon has also spiked. It is also worth noting that the improved recovery rate of polysilicon materials from solar panels can further increase economic and environmental benefits.
결과적으로 폐기 처리가 어려워 오히려 환경 파괴가 우려되던 대표적 재생에너지 태양광 발전의 안전한 보급 확대에 기여할 것으로 기대됩니다.
Today we have learned about the low-cost solar waste panel recycling technologies and the facilities developed by KIER Institute of Energy Research, which I believe will greatly benefit both the environment and economy. I also look forward to a future where this technology can be used for the benefit of many other nations.